Imagine your professor asks you to write a program that stores the exam scores of every student in a class of 100 people. Would you really want to type out 100 separate variable names, one after another? There has to be a better way, and in the C programming language, that better way is called an array. If we store each score in its own variable, our code grows painfully long. We would need 100 uniquely named variables, and looping through them to find the highest score or compute an average becomes nearly impossible, because there is no way to say, "Give me the next one," when every variable has a completely different name. An array is a single block of memory split into equal-sized slots that sit right next to each other with no gaps in between. This is called contiguous memory. Each slot has a position called an index, and in C, indexing always starts counting from 0, not 1. Because the slots are contiguous, every element also lives at its own memory address. Let's zoom into the element at index 2 and see exactly where it sits in memory. So what is the actual address of the element at position I? To figure that out, we start with the base address, the address of the very first element, index 0, and add some offset to reach the ith element. That offset depends on two things: how far in elements we are from the start, which is simply I, and how many bytes each element takes up, which is the size of the data type. Multiplying these together tells us exactly how many bytes to skip. Putting it all together, the address of any element R of I equals the base address plus I multiplied by the size of the element type. This one formula is exactly how C turns R bracket I into a real memory location instantly without ever walking through the array one slot at a time. Let's put real numbers into that formula. Suppose we declare an array of 5 integers, and suppose the array happens to start at memory address 1000. In C, an int typically takes up 4 bytes. Now let's find the address of AR bracket 3, the element holding the value 40. We substitute base equals 1000, I equals 3, and size of int equals 4 directly into the formula. 3 times 4 is 12, and 1000 plus 12 gives us 1012. So, without ever scanning through the array, C jumps directly to memory address 1012 and reads out the value 40. Let's bring it all together. An array stores many values of the same type in one contiguous block of memory. Indexing always starts at 0, and the address of any element can be computed instantly using base address plus the index times the size of the type. That single formula is what makes arrays one of the fastest and most fundamental tools in the C programming language.